Hi, and thanks for watching this presentation. I'll be presenting hatred is in the eye of the annotator. Hate speech classifiers learn human life social stereotypes. This research has been conducted in a collaboration with Muhammad Atari, Brendan Kennedy, Sharia Havaldar, and Mostafazadeh. As a gentle trigger warning, this presentation includes social media posts that can be offensive or upsetting. Natural language classification models rely on human annotated datasets for detecting a phenomenon of interest. In this sense, these models tend to learn semantic associations between the textual data and the phenomenon of interest. Along with task-related associations, these models also learn human-like biases that are embedded in the data representation. In the case of hate speech detection, since the construct of interest is closely related to group derogations, which is rooted in social stereotypes and prejudice, evaluations of the trained models has revealed biased behaviors towards social group terms. Bias in machine learning generally refer to those behaviors that are not generalizable. Such that a biased machine learning model can perform well on a specific task and data set while generating higher error rates on different portions of the data. Since hateful language targets individuals or groups based on their social group membership, biased hate speech detections tend to be overly sensitive about mentions of social group tokens. As a result, non-hateful comments that mention these social group terms are highly probable to be detected as hate speech. Here, we study this effect, which is also referred to as the false positive error for specific social groups as a sign of unintended data-driven bias. Different components in the process of training a model can introduce bias. Data selections based on keywords or topics can create imbalanced data sets in which social groups are associated highly with hate speech. Later, during the annotations, annotators would bring their own social stereotypes and beliefs and create imbalanced data sets. Once these data sets are the input for training a model, the model design can also be a source for bias, where the model would overly rely on the keyword. And as a result, the model would generate more false positive prediction. Moreover, the data representation or the semantic representation, which we also refer to as word embeddings, always include real life biases that can be embedded in the model as well. In this study, we specifically study annotators and how they bring their own biases into the model. The stereotyping, along with other cognitive biases, impact the way individuals create their own subjective social reality as a basis for social judgments and behaviors. In the case of hate speech detection, where the task depends on individuals' judgments about hateful language produced by other individuals, stereotypes about social groups can shape a subjective social reality and affect subsequent judgments. To quantify the effect of social stereotypes on the task of hate speech detection, we rely on a stereotype content model, which suggests that a stereotyping and perception form along two dimensions of warmth and competence. Hence, the different social groups can be represented in different locations in this two-dimensional space based on how they are perceived. In this presentation, I discussed two main points and the studies to evaluate them. First, social stereotypes of targeted groups affect annotations. And then bias in hate speech detection is related to social stereotypes. In the current studies, we explore an annotated data set of hate speech, which includes 27,000 social media posts randomly selected from Gad, which is a social media that claims to stand for free speech. Each post is annotated by a minimum of 3 expert annotators. The resulting data set includes 92,000 annotator post pairs. The Feller's kappa agreement of the whole annotation is equal to 0.23, which suggests that variations in annotators' behaviors and judgments is detecting hate speech. In the first study, we explore whether social stereotypes are associated with disagreements in annotation. We explore inter-annotator disagreement as it relates to the occurrence of particular social group tokens in posts. We ask whether the stereotype associated with social group terms as mapped computationally in English can explain why annotators label some posts differently. To analyze social stereotypes quantitatively, we explore 56 social group terms that are gathered based on previous studies, and we use a distributed semantic space of English, which is also known as the GLOV word embedding, and 2 dictionaries of vocabulary that relating to warmth and competence. So given a social group term represented in the semantic space and the presentation of each of these 2 dictionaries, we calculate the warmth and competence score of the social group term as its average similarity to the words of the 2 dictionaries. To associate these agreements with social stereotypes of the mentioned groups, for each post, we calculate the Feller's agreement of the annotators and also the warmth and competence of the social group that is being mentioned in the post. Associating these warmth and competence scores to the disagreement, we found that warmth and competence score of the social group terms were predictive of the post intercoder agreement, such that higher warmth scores were associated with lower agreement, while higher competence scores were associated with higher agreement. So as a summary, posts with social group terms that are stereotypically warmer elicit less agreement among expert annotators and more likely to be labeled as hate. On the other hand, texts that include a stereotypically more competent social groups were highly agreed upon by annotators and were less likely to be tagged as hate. In the second study, we look into trained models and how the social stereotypes are associated with the bias towards social groups in these models. We specifically look into false positive bias as it associates with social group terms. This effect is usually caused by imbalanced data sets. When a particular social group term is highly associated with hateful language in an imbalanced data set, when the data is used to train a model, the model is more probable to learn such associations. As a result, model predicts positive label for non-hateful posts that include that specific tokens. This effect leads to blocking posts that include that social group term and consequently underrepresents that group. Here, we use 80% of our data set to train a classification model based on BioSTM. Afterwards, we use the 20% test data set and all the posts that include social group terms. In these posts, we substitute the social group term with all possible social group terms from our data set. The resulting test set includes equal number of cases for each social group. We looked into the false positive predictions for each of the social groups. As you can see, for an actual post in the test set that includes a social group term, We substitute the social group term with all other possible groups. And we counted the number of times that a false positive prediction has been calculated. Using a Poisson model for predicting the false positive labels, we found that social groups that are stereotypically perceived as warmer have higher chance of being associated with false positive errors. On the other hand, social groups that are perceived as higher incompetence have less chance of being associated with false positive errors. So as a summary, we put the hate detection classifier to an experiment where we change the social group term in each post with all possible social group terms in our data set. We use the count of false positive predictions to operationalize the classifier's bias towards a specific social group. When a social group term is replaced with a stereotypically warmer and less competent group, the text becomes significantly more likely to be tagged as hated speech. In the third study, which is a work in progress, we wonder what annotator characteristics can explain disagreements. While crowdsourcing solutions tend to increase the agreements between annotators, we believe that the disagreement includes information about ambiguities of the text and the task in hand. Therefore, we look into human differences as a way for explaining such variations in their decision-making. While previous research has shown that expert annotators identify hated speech in textual data more accurately than non-expert annotators, we observed in our studies that social stereotypes about different social groups leads to disagreement in identifying hated speech. Therefore, we are looking into different characteristics of annotators, namely the implicit and explicit biases towards different groups and their attitudes about hate crime and their demographic details to explain their variations in decision-making. In this study, we collect a set of social media posts that are highly ambiguous in the sense that they acquired high disagreement scores in our data set. We ask annotators to label these posts based on their hateful content. In opposed to expert annotators, we expect higher levels of disagreement and human differences. So in conclusion, in study one, we found that annotators agree less on posts that include social group terms that are perceived as warm and less competent. In the second study, we looked into models that are trained on such annotation, and we saw that the model bias is also towards associating hated speech to groups with higher warmth and lower competence. In our third study, we are looking into human biases to human features to quantify and explain these disagreements. Thank you for listening to this presentation.